Welcome to Infini Scale Models. I'm Jason, your host, and I do models. Today we're going to do a little bit of troubleshooting and design of a game I'm working on. It's been a little bit since I've messed with it. It is my code crack game, and we're going to just mess around with the oscilloscope, do some basic capture, some capture stuff with the meter. The on-screen oscilloscope's not working, but I set up a camera to hopefully so you guys can see it to capture it. So I have the scope there. It's not the best, but it's all I can do because, like I said, the screen capture is not working. Hey, David, how's it going? So we're going to work on this right here. This is my code crack game. It is a logic-based circuit that uses a rotary encoder to send a data and clock signal to a serial, serial in to parallel out logic chip that displays on an LED grid panel. So what I'm going to do is I'm just going to power on my DC power supply so I can have 9 volts. I don't need to put it on the screen. It's just 9 volts. It's nothing exciting. 500 milliamps. So if I plug this into my board here and I turn on my power supply. Okay, so as you can see here, oh, didn't even plug it in. Hold on. It goes there. That goes there. So if I come in here, I can manipulate that, and if I wanted to match the code there, I could just come in here. Yeah, well, I'm off a little bit, but the point is you can set a master code with the set of dip switches, and then the trick is to go through the different levels of code as quickly as possible and beat the different levels. And currently at this stage I don't have any levels stored in, so I am actually working on adding a memory system. I have some RAM chips here and some inverters, so I'm going to, hey Phil, how's it going? Yeah, that's fine. I'm going to be doing some stuff with the oscilloscope, capturing signals and stuff like that, so it'll be pretty interesting. So that's the basic premise of the game. This is going to be a memory module. I have a program counter that's going to count through the 16 different levels. It's basically going to be 16 levels from 0 to 15. So, and then on the memory chips, these are LS 74 LS 189s. Then I have a couple 74 LS04s. I believe they're inverters. And then I have a LS 14 74 LS14, which is a hex inverter or a 6 output inverter with a Schmidt trigger. And then I have a serial in parallel out 74 LS164 that controls the actual code crack game. So I've hooked up some of the memory here, so I need to figure out what else I need to hook up here. So I have the dip switches on this set, so I can turn on this. So this will be what I set the memory to. This is my write the memory. So now I need to output the memory. So then I don't have all the write enables lined up here. So looks like I have 2 left to do. So let's pull up the data sheet for the LS189. LS189. So let's do 74 LS 189. Let's pull up this data sheet because all the outputs need to go through the inverters, so it's definitely a 74 LS 189, right? Yeah, 74 LS 189. Why is that not giving me a data sheet? Yeah, 74 LS 189. What? That is strange. Huh, that is strange. That is a Texas Instrument chip, but I can't find a data sheet on it. Let me go to my files here. That is weird. I just find my chip data. Data sheets. 74 189. Okay, so my cloud is not on. Okay, that's interesting. Hopefully this isn't, sorry, this is getting insane. This was supposed to be done and easy, but I need the data sheet for this to work. It's not letting me into my cloud server. I don't think my computer likes to do a stream, record, and there we go. There we go. Is this going to work now? There we go. Now I have the data sheet. Okay, so let's go to this screen here. So here is the data sheet. We have our address lines A1, A2, A3, A3. Okay, we got 0, 1, 2, 3, and 4. 1, 2, 3 are address lines. Then we have our output, which is inverted for some odd reason. And then we have our data inputs. So we are putting the same. No, we're not putting the same. So currently I have, how many bits do I have lined up here? I got 1, 2, 3, 4, 5. So I have the last 2 bits to do. So they need to go to this chip over here to 3 and 4. So pin 10 and 12. So we got pin 10 and 12 on this side. So let's get some wire here. Okay, so I'll get some wire. So I need pin 10 first, so let's go 9, 10. So pin 10 here. Well, let me find these. So we have pin 10 is right here. Come down. Like so. And we'll go ahead and cut that off. And it's going to go here. So cut it right there. Alright, take that out because I need to strip it. Now this should be set still. Nope, it's definitely not set right. So we come back here to pin 10. And we come over here, so there we go. That wire is not going to sit as neat as I would have liked it to. So, but hopefully it'll be fine for testing. I can fix it later. So now we need pin 12. That should have tucked in there. So then we have pin 12 is right here. So cut that off and move that up a little bit. That seems better. Pin 12. Excuse me. If I can get this out here. My allergies are not treating me good today. So this may be a very boring video and it may not even work. I may have to do a bunch of diagnostics on it. Okay, so my data input pins are hooked up. My address is hooked up. Now I just need to hook up the outputs. So this shouldn't be too bad. The outputs, so my least significant bit is this one, and that goes to output 1 or data 1. So output 1. So pin 5. Pin 5 needs to go to... I need to pull up another data sheet here. What is that? Data sheets. What is that? That is a 04. LS04. Okay, fantastic. Can't open my file. That's weird. Okay, so that's just fantastic. Okie dokie, so let's try... LS04. There we go. View it. Okay, hopefully that picked back up because the stream died there. I'm just going to make sure that it comes back on. Yay, it worked. Okay, so that was weird. Wow, man, my computer is saying all kinds of stuff. It's messed up. Okay, so I got the data sheet. So, pin 3. Okay, so pin 1, 3. We'll do pin 2 and 3. Pin 2 and 3. So 4 goes to pin 3. So pin number 4. No, not pin number 4. Pin number 5. Pin number 5. Pin number 5 will go to pin number 5. So 1, 2, 3, 4, 5. Alright, so hopefully this is still working. If not, it is fine, I guess. So 1, 2, 3, 4, 5. That'll work. So now I have to go through this inverter to get the correct output. Okay, so that'll hold those wires down too. So then we have our data pin. So number 2 is, output 2 is pin 7. Pin 7 needs to go to pin 3. I messed that up, but okay, well 7 reach. So 7 needs to go. That one's longer. Okay, so pin 7 needs to go to pin 2, so that works out. Seven needs to go to pin 2. Yep. No, pin 3. Dang it. Pin 7 goes to pin 3. Or we can go to pin 1. That'll work. Pin 1 will work. Okay, so now we have on the other side of the chip, we have input is 9 and 11. So number 3 will go to, so pin 11 will go to, 11 will go to 9. So pin 11. So pin 11 will go to pin 9. So pin 9 is right there. I probably shouldn't work on this while it's live. I mean, it probably wouldn't hurt anything, but I'm just doing data lines. So pin 9. Okay, pin 9 there, and then we have... Okay, that was supposed to be number 3, but I did pin 11. So we will do pin 9 to pin 9 to pin 11. So pin 9, this is going to be tricky to figure out. So pin 9 to pin, oh, what do I got here? Can I go to pin 13? I can go to pin 13, so there we go. That worked out. Okay, so I need to write this down real quick, how I have this laid out, so I know what my least significant bit is. So when I hook it up to the lights, it doesn't give me an error. So data pin, output 1 is pin 5, and it's going to pin 3, so pin 6. So 1, 2, 3, 4. 4. This one is pin 6 of the A, and this is the B one. So that's pin 6, and then the next one is going to pin 1, and that is pin 2 as the output. So that is pin 2 for the output. And then we have the pin 9 is going to pin 13, so 12. Output pin 12 is that. And then this one is going to pin 9, so it's output pin 8. So output pin 8. So that's our first 4 bits, hopefully. Hopefully that's our first 4 bits. So now we have to do the next thing here. So we need pin 5 on this chip. So we have pin 5 on this chip going to excuse me. So let's get this down here. So this is going to go here. Here. This is going to go to pin 5. So that again is going to be output pin 6 on this one. So now this one needs to go to pin 1 here. Is it pin 1? Yeah, pin 1. I don't know if anybody's watching this, but you know, this is how it's done. I mean, it's not all, you know, ooh, it worked right away. You know, you have to run wires and test things, and so that is going to be output pin 2. Pin 2. So let's grab another one of those. So this one is pin here. Pin 9 is going to go to pin 13. Pin 13, we'll just leave it like that. So this is going to be output 12. And then we're just going to plug this one into here. And we're going to loop it and plug that into pin 9 there. Okay, so this is going to be output pin 8. Okay. So we have that hooked up. So theoretically, we should be able to assign an address and dump whatever's in the that we set here. We should be able to dump it into an address, and then we just need to see the output of that address. So how do I want to do this? I need to put another output unit on here somewhere. I would need to output it to this one, but without just running jumpers. I guess I could just run jumpers temporarily to see if it would work. Okay, so let's just get the whole thing of jumpers out. So I'm just going to run jumpers, and then if it works, I will run the wires, hardwire it. So the first one is output pin 6. 1, 2, 3, 4, 5, 6. So that is no, that is this one. Nope, this is that one, and then we have output 2. Pin 2 goes to this one, and then we have output 12. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. 12 goes here, and then we have number 8. Pin 8 goes here, and then we come back over to this other chip. Oh, this is making a mess. It's making me ill. Okay, so then we have output pin 6. 1, 2, 3, 4, 5, 6. Pin 6 goes to here. And then we have output pin 2. 2 goes to here. And then we have some more long wires here. Okay. So then we have 12. So there's 12 right there, and that'll go right there. And then we have one more long one. Output pin 8 to this one here. Okay, so if I turn all these off, so if I turn this on, and so Huh. That's strange. So each memory has something different in it. So I'm getting outputs. As you can see, I'm getting outputs for different memories. Like there's memory location 1, there's memory location 2, there's memory location 3, there's memory location 4, there's memory location 5, 6, 7, 8. So I'm getting memory, but why can't I store into my memory here? So what is going on here with my write enables? Wait a minute, does this need a stupid clock pulse? Shouldn't need a clock pulse. No, it needs write enable pin 3. What is chip select? Okay. The outputs 3 state are high impedance. So chip select needs to be low, and what pin is chip select? Chip select is pin 2. Pin 2 is low. Pin 2 is low on both these chips. Okay, so address select, yep. Chip select input. Write enabled. Is that being pulled? Right now, it needs to be low. Chip and write enable needs to be pulled low. So let's reverse the LED. Let's reverse the LED and plug in this to ground. I should be pulling pin 3, which is pin 3 is write enable. Write enables pin 3. That should be pulling pin 3 low. Let's do this. Let's take that out. Let's do... Oh, come on. Where did that go? It went there. Okay, so... that should be getting an active low signal and setting that to the data. Okay, let's do it this way then. Let's pull the switch out and see if I give it an active low directly. Nope, that doesn't change it. What if I give it an active high? Nope. Huh. What if I make chip select an active high? Chip select is going to now be high. This is the part of troubleshooting. Okay, so let me dump this low real quick. And no, that did not write the data. So that's definitely not writing the data. Is it even outputting anything? No, now it's not even outputting anything. So it's definitely not the way to go with chip select. Chip select needs to go back to low. See, now at least it's outputting something. Let's go to address 1 and let's write. So I wrote 0 to address 1. So I definitely wrote something to address 1. Okay, so I wrote nothing to address 1. That's progress. Can I write something to this address? Which is nothing again. So somehow my inputs are connected to the wrong thing. Let me you know what? They're all being pulled low by this resistor here. Why would I put that there? Why would I put that there? Okay, so so now I know why that's there. Okay. So let's just try something here. Let's see what this does. Okay, so I definitely wrote some data there. I wrote high to everything. So now everything is being written high because I pulled that resistor out. Okay, so this is where we're at here. These data lines are wrong. So let me plug in my resistor array back so I can get my LEDs to work. Yep. Now if I write that, it goes to all zeros because I'm pulling it low. So I need to move my data outputs to wonder if I could pull this out of here and pull this out of here and flip it around and plug it in there like that. And plug this into there like that. Okay. No, it's still pulling it low. This has got me. Wait. Yeah, I'm still pulling the whole line low. Okay, well, hey Jason. Hey Jonathan, how's it going? Yeah, I had my fill of this. This is already starting to irritate me. I have to figure this out. I'm not going to sit here and bore the stream with me figuring this out. I'm doing something and I'm missing something simple and I can't figure it out at the moment, so I'm going to call it here. Thanks guys for watching.